All right, I've got a nice quick Codewars challenge for us today. For this exercise, you will be strengthening your page foo mastery. You will complete the Pagination helper class, which is a utility class helpful for querying paging information related to an array. The class is designed to take in an array of values and an integer indicating how many items will be allowed per each page. The types of values contained within the collection or array are not relevant. And here's some examples of how this class is used. So we start with a pagination helper, and it looks like we give them the array we want to have help paginating, and a number of how many items per page. And then we have to implement these methods so that we can get the right information back about how to paginate or paginate this array. So we've got page count, page item count, and page index for an item index. And there's more info over here. So this is pretty simple. It's mostly just mathy stuff. So what we want to do is when we are instantiated here, we want to save the collection that we are passed and the items per page so that we can reference those later. So we can replace this pass with self.collection equals collection and self.items per page equals items per page. Okay. And now we have that info. And since we are going to want the page count down here, and it looks like that's not going to change, I'm going to just pre-compute that here. So self dot, let's say num pages, because page count is a method down here. We don't want to mess with that. So we got to name it something else. Self dot num pages equals, and now here's where we got to think. So if we want 4 items per page, let's use this as an example. 4 items per page. You can see pretty quick just looking at this that it's only 2 pages, because here's the first page, there's the first 4 items, and then the next page is going to have the last 2, and that's the last page. So it has 2 pages. But the math behind that is we can take the number of items overall and divide them by the number of pages. So let's pull up Python here. Python. Right. This is going to help us do a little bit of math. So if we have num items equals 6, there's 6 things there, and items per page equals 4, what we want to do is use these 2 numbers to get the number 2, because that's how many pages there are. So we want back to here. Okay. And the way we can do that is we can divide 6 by 4. So num items divided by items per page. And that gives us 1.5, which is kind of close to 2. And it just works out that if we always just round up, it will always give us the right number of pages. So if we say import math, and we use the ceiling function to round up this number, so math.ceiling of num items divided by items per page, then that will give us 2. And we can try some other numbers here. Num items equals, let's say 13, unlucky number, and items per page equals 4. So we can see that this is going to be 4, 8, 12, so that's 3 pages, and then 1 more page for the last item there to 13. So we should get 4 pages here if we use this calculation again. And that's what it says, so 4. So this is what we need. Math.ceil num items divided by items per page. I'm just going to use that here. We're going to import math like we did. Import math. And then num pages equals math.ceiling of the length of self.collection divided by self.items per page. And since we're going to use this length here, it really doesn't save that much time, but I'm just going to make another method, another property to save that. So self.num items equals the length of our collection. And we can use that value here, self.num items. There we go. Okay, now the item count is really easy. We just return self.num items. Hopefully that makes sense. We got that from the length of our collection, and this is asking for the length of the collection, so we just return that. The page count, that is a little more tricky. It says it returns the number of pages. So, oh, I guess that's not any more tricky because we already computed that. So we can return, oh, we got to return that. Return, and then return self.num pages. There we go, 2 methods down and the constructor. And we got 2 more, page item count. So we want to see how many items are on the page that we're looking for. And it says we're going to give the page index. So here with 4, page 0 is ABCD, page 1 is EF. And the way we can generalize this for any array and any page size is if we are on any page except the last page, then the number of items on that page is always going to be the items per page. But if we're on the last page, it's going to be however many you're left over with if you take the remainder after dividing the length of this by 4. And that's a lot of math, but I'll show it to you. It's called the modulo. It makes it really easy. So page item count, it also says we need to return -1 if the page index doesn't make sense. So let's take care of that first. So if page index is less than 0, so if we ask for page -1, that doesn't make any sense. So that's an error. Or page index is greater than or equal to our number of pages. Then, so greater than or equal to, I guess I can explain that. So we have 2 pages here, but the page indexes are 0, this is page 0, and this is page 1. So if we ask for page 2, it's not going to know what to do because there is no page 2. There's only page 0 and 1. So that's why we need to have, if the page index is equal to the number of pages, that's still out of bounds. So if any of that's true, then we return -1. All right. That should take care of our errors. And now we need to check if we are on the last page. So the page index. So if the page index equals self.num pages -1, so if we're on the last page, then we want to say, we're going to have to do our fancy math. So the fancy math is num items. Oh, we can just return this. Return self.num items mod self.items per page. And the way that works is since items per page is 4 here, and we have 6 items, then we're going to divide 6 by 4, but then take the remainder after that. So what's the remainder after dividing 6 by 4? Well, 4 goes in 1, and then the remainder is 2 here. And that tells us how many items there are on the last page. So that is what we've done. So we've divided the number of items by the number of items per page, and ask for the remainder, which is going to give us 2. Or in the general case, is going to give us the right answer. Is it items per page? Let's check that. Yes, items per page. Okay, we're good. And now we can just, since we're not out of bounds and we're not on the last page, we know that we are going to be able to just return the number of items per page. Because for any page that's not the last page, it's always just going to have 4 here. It's always going to have the number of items per page. Okay, that's 3 of them. And now the last one is, this determines what page an item is on. Zero-based indexes. So again, we need to return -1 for an item index value that's out of range. We can take care of that real quick. So we can just copy this actually and adjust it. This is, if you're copying code and adjusting it, you always have to be really careful. So we need to make sure we change the things that we need to change. If item index, so instead of page index, we're looking for item index. Item index is less than 0, or item index is greater than or equal to not our number of pages anymore, but our number of items. Then we can return -1. Otherwise, we are in the right range, and we're going to have an answer to return. So let's just do an example. This E has index 4. It's 0, 1, 2, 3, 4. So, what page index is this E on? Well, since we know the page indexes already, this is 0, this is 1, so E is on page 1. And a really easy way to tell that is we take the index and divide it by the number of items per page. And then we take the floor of that instead of the ceiling this time. So that works for 4 divided by 4 is 1. 3 divided by 4 is something less than 1, but we can round that down to 0, and that's the right page here. So 0. That works for any of these indexes. And then F, that's index 5. So 5 divided by 4 is something a little more than 1 and a little less than 2. So we can round that down to 1, and that's page 1. It's the right page we're on. So we can say return item index divided by, let's actually make that explicit. So math.floor item index divided by self.items per page. And that is it. Let's run our tests. Pass that test, and we can run the attempt and run all the rest of the tests. There we go. And we passed. Okay, well, thanks for watching. Let's see what other people did. Submit. What did we do? What else did people do here? Looks like, yep, just save that. Item count, they didn't cache this value. They just called the length function again. That's okay. Page count. So they didn't use the fancy math that we used, but that still works. Page item count. If page index is greater than or equal to this page count, -1. Well, oh, interesting. Else, if the page index is equal to our page count -1, then so this actually doesn't cover the bug that would happen if we put in -1 for this page index. So I could break this code. If I put in -1 for the page index, it would say it's not greater than or equal to that. Okay, and it's not equal to the last page. Then we can just return the number of items per page, which would be incorrect because we asked for how many items there are there on page -1. So this is actually broken. That's interesting. Determines what page an item is on. Zero-based indexes. if the item index is greater than or equal to our number of items, or item is less than 0. So they caught the less than 0 here, but not up here. That's interesting. And then they did the same thing. You just return the item index divided by number of items per page. I'm not sure why they didn't floor this, because it should be returning an integer. At this point, it might return a float. Maybe they're depending on just Python coerces floats into integers most of the time. So maybe that's what they're depending on. So that's not really safe, but I guess it worked for them. So there you go. All right, thanks for watching. Let me know any questions I can cover again. And feel free to come back when I upload more videos. Thanks, bye.